So now let's discuss solving linear equations involving fractions. Okay, but before we start with the actual solving, let's first recall your understanding of what LCM, because this one is gonna be useful in this topic. So what do you mean again by LCM? It means least common multiple. Least common multiple. Okay. Sir, how do we identify LCM or least common multiples of numbers? Okay, let's say we have the number 2, we have 3, and then we have 5. And then you're being asked, what is the LCM of the numbers 2, 3, and 5? How do we do that? Actually, there are a lot of approach here. I mean, there is some mathematical computations, and then also there are basic methods or basic ways like listing. And this time, we will just be dealing first with the listing method. So what do you mean by listing method? Remember, LCM means least common multiple. The word is multiple. So what do? Is we will first list the multiples of these numbers 2, 3, and 5. Okay, I will ask you, what are the multiples of 2? We have, okay, where's my cursor? Yeah, there we go. Okay, multiples of 2, 3, 5. Okay, let's start first with 2. Multiples of 2, we have 2, 4, we have 6, 8, 10, 12, 14. This might be a bit long, okay? 16, 18, what's next? 20, 22, 24, 26, 28, 30, 32, and so on and so forth. Now, we go with we go with 3. What are the multiples of 3? We have 3, 6, 9, 12. What happened? Okay, 12. Let's go here. We have 15, we have 18, 21, 24, 27, 30, 33, 36. And then for 5, your very favorite number, we have 5, 10, 15, 20, 25, 30, 35, 40. Okay. Now, upon listing, actually, it's gonna be taking a long time, huh? I mean, if it's this thing, most especially if the LCM is big. So we have 2, 3, and 5. Okay. Now we're done with with enlisting the multiples, right? What we do next is we will check the least common. When you say least common, we have to check on the common multiples among the three. That is the smallest. Can you check what is the common here? Actually, that is what? That is 30. 30. All of them, they have multiples of 30. That's why the LCM of 2, 3, and 5 is actually 30. Sir, how come 30? Because it means that 30 is the smallest number divisible by 2, by 3, and by 5. Okay? So let's see. 30 divided by 2, that is 15. Exact answer. No decimal point, no remainder. Next, 30 divided by 3, that is 10. Also exact. No remainder, no decimals. And then 30 divided by 5, again, that's exact, and that is 6. And we will be applying this in discussing solving of linear equations involving fractions. And actually, we have here a lot of examples. Okay, let's start. Number 1. So we have here 7 over 10 n plus 3 over 2 equals 3 over 5 n plus 2. Last time, what we have is the coefficients. What's the thing by coefficients again? The coefficients are the number before the n or before the variable. Last time, our coefficients are whole number. The only difference this time is just its fraction this time. However, the procedure in solving for the variable, it's still the same. What will just change is that initially, we have here fractions as our coefficients. So, sir, how do we do that? Remember a while ago, I taught you about LCM, this one. We will actually apply that one here. What do we do? First, we will get all the denominators. What's our denominator here? We have 10, we have 2, and we have 5. Okay. What are the LCM of 10, 2, and 5? Everyone. I, I thought I'm in class. I thought I'm in class, sorry. So 10, 2, and 5. What are the LCM of 10, 2, and 5? Again, now you can use this one here, this method by listing. But to save time, actually, the LCM of 10, 2, and 5 is what? It's actually 10. Sir, why 10? Sir, why 10? LCM equals 10. Sir, why 10? 10 because 10 is the smallest number divisible by 10. Let's check. Divisible by 2. Let's check. Divisible by 5. Let's check. 10 is the smallest number divisible by 10, 2, and 5. So what do we do now? We have to convert all of this one, this one, this one, and this one, all of those terms into a fraction with denominator 10. Sir, how to do that? Again, we have to convert all of them into a fraction with denominator of 10. I'm just trying to rewrite them now. All with denominator 10. So how do we convert that one now, sir? Okay. This one, 7 over 10 n. No need to convert, sir. Why? Because it already have a denominator of 10. Nothing will change anymore. So just copy 7 over 10. Now, what about 3 halves? Its denominator is not 10, right? It's 2. What do we do, sir? What we will do is this one, ha? This is 10. This one, 10 divided by 2. What's that? That's 5 times 3. Just focus on this one, ha? Focus here, focus here. So 10 divided by 2, that's 5 times 3 is 15. Next, same thing. 10 divided by 5, that is 2. Right? One more time. 10 divided by 5, that's 2. Times the 3 numerator. 2 times 3 is 6. One more time. 10 divided by 5, that's 2. Times 3 is 6. Now, sir, what about the 2? 2 doesn't have denominator here, but a whole number has denominator, right? What's that? 1. What's 10 divided by 1? That's 10 times 2. That is 20. Okay, you can actually try to go back again in the video if it's not yet clear. And then what do we do next, sir? Actually, we can do here already some magic. What do you mean magic, sir? I can cancel out already all the 10 there. How come, sir, you cancel that? Okay, actually, I can already accept that you cancel it right away. But what's the reason behind? When you actually multiply all these numbers here with 10, all the denominators of 10 will be cancelled. That's why what we will just do is, after this one, we will just get all the what numerators. You have here 7 times n, that's 7n, plus 15 equals, what 6 times n? That is 6n, plus 20. I hope there's no question so far. What do we do next? This time, we will just go back to our solving of linear equations, our previous topic. So how do we solve for n or the variable? Make it solo, make it positive. So 7n and 6n, those are the two with variable. Which one is smaller? 6n. So I will just adjust or I will transpose the 6n to the left. So if I will put all those with variables to the left, those without variables will be placed to the right. Now, what will happen to 7n? Is still nothing, right? Because 7n is just retained. And then 6n will become negative 6n equals 20 is just retained. However, 15 will become what? Negative 15. Next, What's 7n minus 6n? That is n equals 20 minus 15. That is 5. That's why our final answer for this one, number 1, is 5. Again, if there's still something not clear here, you may try to rewind or go back again in the video. Or if it's still not clear, you can ask me. Next, number 2. We'll proceed right away, yeah, because we have here a lot of examples. Okay, what are our denominators? Again, first thing you have to do is check all the denominators. What are our denominators here? We have 7 and 7. Any other denominators? No more. Okay, so what do we do? We get the LCM of 7 and 7. I guess it's kind of obvious, right? What's the smallest number divisible by 7? Obviously, that's 7. So, what do? Is we have to convert all of this into a fraction with denominator 7. So, over 7, I'll just copy the n, minus 6, sorry. Ah, sorry, it's actually hard to delete from here. Sorry for that. Where's the eraser? This one. So, I'm so careful in writing because it's hard to erase in PowerPoint. Anyway, so let's proceed. Again, your goal is to convert all of them into a fraction with denominator 7 equals over 7 and then n plus 4. Okay, let's start first with the first one. 1 over 7. Do we still need to convert this? Actually, no need, sir. Why? Because its denominator is already 7. No need to no need to convert, right? So already 1 over 7. Next, how about the 6? What is the denominator of 6 here? You have 1, right? What is 7 divided by 1? That's 7 times 6 is 42. And actually, you can check it. What's 42 divided by 7? That is 6, right? Next, equals. Okay, this is 3 over 7n. Do we still need to convert? No. So, we'll just copy this. Next, how about the 4? Okay, I made a mistake here. I'm so sorry again. It's hard to erase here. There you go. Then go back to pen. Okay, that's why I should be careful here. Again, because your goal here is right, you have to make all of their denominator 7. Now, what's the denominator of 4 here? 1. What is 7 divided by 4 by 1? 7 divided by 1 is 7 times 4 is 28. And actually, again, you can check. What's 28 divided by 7? That is 4. I hope you can still follow. Again, what do we do next? We once all of them have already common denominator. Again, all of them. We can just simply ignore the 7. So why? Same thing with the number 1 here. When we're going to multiply all of them with 7, all the 7 here, both left and right side will be cancelled. Now we have left is 1 times n. Do I need to write 1n? No. 1 times n is simply n. And then copy the operation minus 42 equals 3 times n is 3n plus 28. Okay, what do we do next? Again, let's check. This one is n, this one is 3n. Which one is smaller? N, right? So we let the n be transposed to the right. Let it be the one to adjust. And then if we will put those with the variable to the right side, of course, put all those without variables to the left. So what will be on the left side? We have here negative 42. Nothing happens to negative 42. Next, 28. What will happen to 28? It will become negative 28 equals 3n. Did 3n move? No, it's just retained here. Now, however, we still have the n. What will happen to n if we will transpose it from left to right? It will become negative n. Let's continue. Negative 42 minus 28, depth and depth, all in all, that's negative 70 equals 2n, right? Because 3n minus n is 2n. What do we do next? Divide both sides by 2, divide by 2, so cancel, n equals negative 35. Or actually, this is already acceptable, but you can also write n equals negative 35. Those two are just the same. So I hope this one is clear. Let's have more examples. Okay, number 3. We have here 5 over 6n plus 1 equals negative 1 half n and then plus 4. What do we do? Again, we get all our denominators. Again, if ever you want to practice right away, you can pause the video, try to answer this one first on your own, and then once you're done answering, you can play back again. So let's continue. We have here 5 over 6 n plus 1 equals negative 1 over 2n plus 4. Our denominators are 6, 2, and 4. Okay, what is the LCM of 6, 2, and 4? Again, think of the smallest number divisible by 6, divisible by 2, and divisible by 4. What's that number? Again, for efficiency purposes, I'm not going to show you anymore the listing. You can just do it on your own, the listing. But the LCM of 6, 2, and 4 should be 12. So why 12? Because 12 is divisible by 6, right? You get my point? Also, 12 is divisible by 2, and 12 is divisible by 4. Now, what do we do? I will just write here, LCM equals 12. So, once we have again our LCM, what do we do? We should convert all of these numbers here, all of them, all of the numbers, all of the terms. We should convert all of them into a fraction with denominator 12. Sir, where did 12 came from again? Again, 12 here is your LCM. Or if it's used in fraction, it can also be called as LCD. Those two are just the same. Okay, let's go. Let's proceed. Now, what do we do again? What is 12? Okay, don't forget the n. I'll just copy the n here. And then plus n here. This is n. And then plus. Okay, what do we do next? What is 12? This one, divided by 6. That is 2. Divided by 6 is 2. Times 5 is 10. Next. What is 12? Okay, now this one is whole number 1, right? What's the denominator of 1 here? Also 1. What is 12 divided by 1? 12 divided by 1, what's that? That is 12 times 1. That's also 12. Also, you can confirm, right? 12 divided by 12 is also 1 equals. Next one. What is 12 divided by 2? That is 6 times negative 1. That is negative 6. I hope you can still follow. Next one. 12. What's 12 divided by 4? That is 3 times 1. That's also 3. Okay. What do we do again? We can just simply ignore all our 12 here, right? So what do we do? What will happen, di ba? We will multiply all of them by 10. And sorry, why not by 10? By 12. And then all the 12 here will be cancelled. And again, what do we do? We will just get all our numerators. What's 10 times n? That is 10n plus this one is 12 equals negative 6n plus 3. No question so far? Okay. What do we do next? Again, let's compare. The one with the variables are 10 and negative 6. Which one is smaller? Obviously, negative 6. So what do we do? Let the smaller value adjust. I will just move the negative 6 and to the left. And then if I'm going to put the variables or those with variables to the left, obviously, I have to put those without to the right. So now, 10n, nothing happens, right? I'll just copy. However, it has a new companion, negative 6n. What will happen to negative 6n if you will transpose it from right to left? It will become positive 6n equals, did 3 move? This one 3. Is 3? No, right? So I'll just copy the 3. Next. However, it has a new companion, the 12 from the right, from the left side. 12 from left to right will become negative 12. Now, what is 10n minus 6n? That is 16n, and then equals, what's 3 minus 12? That's gonna be what? Negative 9. Okay? So what do we do next? Again, try to remember, your goal here is to solve for the value of n by making it solo and positive. Is n already solo and positive? Not yet, because we still have here the 16. What do we do? I will divide this by 16, but if I'm going to divide the left side by 16, take note, also divide the right side by 16. Now, what will happen here? Cancel the 16, n equals negative 9 over 16. I hope this one is clear. Let's proceed. Number 4. So we have here 3/4 n minus 18 equals 1/4 n minus 4. Okay. What is our, what do you call this one? What are our denominators here? We have 4 and 4. Obviously, when you're going to compute with LCM of 4 and 4, it's 4, right? Okay, our LCM here is 4. What do? We have to convert all of them into a fraction with denominator 4. Okay? So what's gonna happen here? So again, over 4, I'll just copy the n minus. This one is over 4 equals, again, over 4 and then n minus and then over 4. 3/4. Do we still need to convert this? Actually, no need. That's why we will just copy. So 3 over 4n. Next, how about the 18? What's the denominator of 18 here? That's actually 1. What do? What is 4 divided by 1? Obviously that's 4. And times 18, 4 times 18 is what? 72 equals, okay, the 1/4. Do we still need to convert the 1/4? No need. Why? Because its denominator is already 4. Minus this one here, the 4. What's the denominator of 4 here? 1. What's 4 divided by 1? That's 4 times 4. That's 16. Actually, we can confirm here, right? What's 16 divided by 4? That's actually 4. Okay? What do we do next? Again, what we will just do, we will just get all the numerators. So we have here 3n minus 72 equals, what's 1 times n? Obviously, that's n minus 16. So how come again the 4 is being cancelled? Because if we multiply both sides by 4, all the 4 here will be cancelled. Now, we have 3n minus 72 equals n minus 16. I believe you can still remember this one, right? So what do we do here? Move the n to the left and then move the 72 to the right. So this one will become 3n minus n equals negative 16 didn't move, right? What will happen now to negative 72? It will become positive 72. What's next? It will now become, what's 3n minus n? That is actually 2n. Next, equals, what is 72 minus 16? What's that? That's gonna be, okay, I have to make sure my answer here. So 72 minus 16, that's gonna be what? You said 56? Let's check. So 72 minus 16. I don't know what's wrong with my calculator. 72 minus 16 is 16. So 72 minus 16, we have here 12 and then 6. It will become 6. 1. Okay. Obviously, that is what? 56. What do we do next? Divide both sides by 2. Divide by 2. Cancel. N equals what? 28. Okay? We're clear so far? Actually, we still have here a lot of examples here. We still have 4, 5, 6, 7, 8. But I will just leave this to you to practice. Okay?